Hey guys, we were interested in knowing how many nutrients were in our aquarium and in this Erlenmeyer flask because this has a clearer looking water and this has a more full of nutrients. Well, we don't know. That's our theory. It has more life in it and more algae, an algal bloom. And so you can see it's pretty clear, but this one is much more clear. Okay. So that's our hypothesis. And I am going to take liquid from the aquarium and from the Erlenmeyer and put them into these tubes. And then I will be testing for ammonium and nitrate. And then I will be looking for a color change to see how much ammonium and nitrate we have in each of these experiments. So I'll just show you this. When I'm getting the liquid out, I have a lot of duckweed on here, and I just want you guys to really see this is duckweed. Okay, duckweed is a tiny little plant that has roots and it floats around on the top. It's right there. So see, it's all stuck around the sides there. So whenever I put in this tube, the pipette, it always gets some duckweed on it. Okay, so I'm going to continue. And oh, there's our little fish. Can you see him? He's our last one. I had like 15 in there. So part of the reason there's so many nutrients is that the fish have died. And when the fish dies, or any of the plants dies, oh look, he's swimming over to it. Can you see? He's interested. Then the detrivores, or the decomposers, change the organic waste, which is dead organisms or dead or feces, changes those into inorganic nutrients for the plants, and then that's why everything starts growing. Okay, I'm going to, it takes me a little bit of time to do some of these tests, so I'm going to start mixing some of the tests, and I will come back in a minute. Hey guys, so I'm just going to show you this as I'm doing it. So I'm adding 8 drops of one solution and 8 drops of another. 3, 4, 5, 6, 7, 8. And then once you've added those drops, you add the lid and you shake vigorously for 5 seconds. 3, 2, 1. And now I'm going to let this color develop for 5 minutes. Okay. Guys, I'm also testing for nitrate. And in the nitrate test, you have 2 different chemicals to add to react with the nitrate that's in the water. And at this point, I'm doing the part where I'm shaking vigorously for 1 minute. And I have each of the different water tests here. Sorry, it's loud outside. Okay, I'll come back. Okay, I'm also testing for nitrite. There's nitrate and nitrite that we can test for this kit that we have. So I'm shaking this and then I'm waiting for the colors to develop. They're all so pretty. And we will come back with results in just a minute. The fish is very interested in everything. Okay, I'm also going to be testing for dissolved oxygen. This is a very different test. I'll explain this later, but you break this little thing and the liquid goes in, and then you turn it up and down. And this is going to tell us how much dissolved oxygen there is. Okay, guys, so this is real science. I don't think my hypothesis was correct. There doesn't seem to be more ammonia. So these are all nitrogen tests, different forms of ammonia. So what I'm going to show you here is this is the clear, the Erlenmeyer one, and this one is for the the tank. What do you think? Very similar colors, right? And so that's going to equate to, for ammonia, a very low amount, 0 to 0.25, if you can see that there. So we're looking at this, we're looking at the ammonia color right here, and it seems as though this color is yellow. There's like no ammonia. Now, if we look at the nitrite, here's the nitrite. I'm going to keep these the same way. Here was the clear one, and here was the tank. They look pretty similar, don't they? So as far as nitrite goes, again, I don't think there's anything in there. And now we're looking at nitrate. Let's see if there's any difference in our nitrates. Looks like maybe there's a little bit of the nitrate here, maybe 2 parts per million, but what do we think? Are those the same color? I think so. So in that case, this would be the nitrate, and it looks to me like there's probably between 0 and 0.5 parts per million nitrate. So let's see if there was a difference in the dissolved oxygen level. So this is a different test. So this one is the okay, same order again. So this color here, and it'd be good to have something white behind it. Okay, now that's a little bit of a difference there. Not much, okay? But basically what we can see here is that the one on the left is a little bit darker than the one on the right. And the one on the right, because I'm keeping these like this all the time, the one on the right is the tank, all right? So for the tank, and this is how you can see this. So it looks like, so you measure this compared to these. So we're looking for the parts per million. So there's not a big difference between these, right? So you estimate, and it's probably between 6 and 8 parts per million for the tank. And for the flask, let's see here. So see, it's more in the realm of between, so where does it match up? It matches up more between the 4 and the 5 parts per million. So not a big difference, but it looks like the tank has more oxygen than the flask. So what does this all mean? We'll have more.